Epson's 3.2 by 2.5 mm RTC module has a wake-up timer function. A wide range of period settings are possible, from less than 1 second to long periods. An interrupt can be output to an MCU in sleep mode at set intervals, which can be used to wake up MCU. The current consumption during backup mode is the typical value when the power supply voltage is 3 volts. Timekeeping can be continued, and current consumption is the lowest. The RTC module outputs an interrupt to the MCU at setting cycle. When the system does not need to operate, the MCU is in sleep mode. When the system needs to operate, the RTC can send an interrupt output signal to wake up the MCU from a low-power sleep mode. Periodic intermittent operation is possible. The RTC module can output interrupts to the PMIC at setting cycle, even in backup mode when it is operating on backup power. For example, in a system that requires periodic operation, when the system operation is not required, the main power from the PMIC is turned off, the MCU is also turned off, and the RTC module operates on backup power with low current consumption. When the system operation is required, the interrupt output from the RTC module triggers the main power from the PMIC to be turned on at setting cycle, and both the MCU and RTC module operate in normal mode. After the required operation is completed, the main power supplied from the PMIC is turned off, the MCU is turned off, and the RTC module operates on backup power with low current consumption. In this way, periodic intermittent operation is possible. Even if the RTC module does not have a power switching function, it is possible to operate the RTC module at low current consumption, and output an interrupt to the MCU at set intervals. This is an image of intermittent operation. The triangles represent the timing of interrupt outputs for each period set by the RTC module. The sleep mode makes it possible to reduce the average current consumption of the system. The longer the sleep mode time, the lower the average current consumption. Extending the sleep mode as long as possible will lead to lower power consumption. However, you must take time shift into consideration. If the sleep mode time is extended, time correction will not be possible and time shifts will occur. With a 32 kHz crystal unit, the frequency temperature characteristics are parabolic shape curve, so the frequency deviation will be large at high and low temperatures, which means the time shifts will be large. The table shows the results of calculating the time shifts versus elapsed time. In reality, deviations on the positive side also occur, but because the frequency temperature characteristics of a 32 kHz crystal oscillator have a large change on the negative side, the calculation results on the negative side are used for comparison. With an RTC module with temperature compensation function, for example, after 24 hours, the time deviation will be within 0.5 seconds. In other words, if time correction is performed once a day, the time error can be kept to within 0.5 seconds. If there are no problems with the system, the sleep mode time can be extended, contributing to lower system power consumption. The wake-up function of Epson's RTC module can be set to a period of less than a second. For example, if you need it to operate constantly and think that intermittent operation is not possible, but constantly means that operation once per second is sufficient, then this wake-up function may be sufficient. Intermittent operation at short intervals makes it possible to lower the average current consumption of the system. Some devices and facilities have a set useful life, and there are regulations that require them to be disposed of after a certain period of operation. Epson's RTC modules include products that can be set to a timer of more than 30 years. It is also possible to count time while the main power is on, that is, only while the RTC module is operating in normal mode. The RTC module acts as an integrator of operating time, and when a certain period of time is reached, it can output an interrupt to the MCU. It is also possible to count time while the main power is off, that is, only while the RTC module is operating in backup mode. It is also possible to count the cumulative time both when the main power is on and off. It can be used, for example, to notify users when it is time to replace consumable parts inside equipment. RTC modules RA8000CE and RA4000CE with a reset function will switch from normal mode to safe mode when the power supply voltage falls below a set voltage. By using this to control the RTC module's power supply voltage so that it falls below a set voltage when the engine is turned off, it will switch from normal mode to safe mode. In other words, the RTC module can operate in normal mode when the engine is on, and in safe mode when the engine is off. This allows the RTC module to operate as an accumulator only when the engine is on, or only when the engine is off. It is also possible to count the cumulative time with both the engine on and off combined. This can be used to notify you when it's time to replace the battery. Epson offers an extensive lineup of RTC modules with a built-in 32.768 kHz crystal units. These products do not simply keep time, but also include products that maintain accurate time even in high-temperature environments and products with various functions. This list is a comparison of the functions supported by RTC module products in a 3.2 by 2.5 mm package size. All RTC module products support the basic RTC functions of time, calendar, alarm, and wake-up timer. The areas shaded in dark blue indicate recommended products for each function.